So what we're going to do right now is we're going to figure out how to solve for the overall entropy, the change in entropy of a reaction by entropies of formation that we find in a table. And what you should be aware of in all types of problems, whenever we have a change in anything, and we put that little zero here for that not symbol for standard conditions, it's always equal to the sum of all the entropy of the entropies of the products times however many moles they have, minus the sum of the entropy of all the reactants times an n. Now, I know that's really messy right here, but in essence, what we have to do is we have to look at our equation and realize, hey, we have 1 mole of this. So that 1 mole of our product, we're going to look up on the table and plug that into here. The 1 is going to go right here, and the actual value we find is going to go right here. Similarly, we have 1 mole of CH3OH and we have 1 mole of CO. Both of these are on the reactant side, so we're going to take those values from the table and put them into here. Now, as messy as I just did this right now, you're going to be able to do the pull-down menu in ALEKS to see what the actual values are. But I'm going to start over here with the products on this side. So my overall change in entropy for my reaction, I like putting RXN in here, is going to be equal to the value, the sum of my products. And if you take a look on the table, we discover that for the products, you have the entropy for this one is 159.8 joules per K. Now, that is all we have on the product side. And we're going to subtract from that all of the entropies on the reactant side. Now, since we have 1 mole of this and 1 mole of this, we're just going to read off what the table has and put them in here in our equation. So when we do that, we realize that the first thing is 239.9 joules per Kelvin. And the second one, which we're going to add to it, is 197.7 joules per Kelvin. Sometimes they have joules per Kelvin mole. I left out the mole on this and this. It doesn't really matter as long as you realize that all the time, this is where they kind of get you, is whenever we're dealing with entropy, we're dealing with joules. So when we do the math on this and we add them all up together, we end up with a value of negative 278 joules per Kelvin. And that's our change in entropy for the reaction. Again, if any of these numbers had been different, now all these right here, the coefficients here, here, and here were 1. So the numbers right here, where the n would be, is 1, 1, and 1. If they'd been any other numbers, we would have been multiplying this problem by 2, or whatever the value was that we'd found in that space. Hopefully this has been helpful. Have a good night.